Okay, quadratic equations, everybody's favourite, and we've got some logarithms to mix up with it. Quadratic equations often take the form of either logarithms or trig or something like that, what we've got here. Let's just quickly solve this first quadratic equation, just get ourselves started. Bit of a warm-up and factorise. Okay, we've got two answers there. Now, moving on, we've got a very similar one. Actually, it's worth noting before we start that in here we've got a 3 to the power 2x, and 3 to the power 2x is the same as 3 to the power x squared. So, compare that to this. And quite obviously what we've got is exactly the same equation where p replaces 3 to the power x, or 3 to the power x replaces p, and so it's going to give us the same solutions. 3 to the power x must be 1/5, or 3 to the power x must be 2. And what to do with these index equations. The way to solve index equations is to take a logarithm, whatever base you care to choose. I would choose one you've got on your calculator, makes life a little bit easier. So log to base 10 is what I'm going to use, and same on this. So logarithms of both sides, that's the way to get into these index equations, and then we can use a rule of logarithms here. That index becomes a multiplier. And so x will be logarithm of 1/5 divided by logarithm of 3. And in the same way, this one will be logarithm of 2 divided by logarithm of 3. Put that in the calculator. Logarithm of 5th divided by logarithm of 3. And just to prove that it doesn't really matter what log base I use, natural logarithms or log to base 10, as long as I can key it in right, which I didn't, and log to base 3, there we go, there we go, same deal. And what have we got? Log 2, log 3, whatever base you want, just make sure you're consistent, and that's my answer. So minus 1.46. or x equals 0.631. Okay, two answers there. Intersection of curves. Before I start, let's give myself a bit of room. I think we'll get rid of that. We should be able to squeeze the rest in here. So we want this to equal this, where they cross. And I do believe we're going to be looking at exactly the same equation here. Let's just check. And if we sort this out, we're going to get exactly this one again. So we know that this will be true and then this will be true, which means the 2 points we're looking for will have the x coordinates that I've got down here. And the y coordinates, well, I could take these and put them back into here. Unfortunately, I've already rounded these, so what I'm going to do is I'm going to go back to this one, where I know what 3 to the power x is, and I'm going to use those to put it in. So if 3 to the power x is 1/5, put them in either. 5 times a fifth minus 2, and 3 to the power x equals 2, put it in here. 10 minus 2 is 8. There's my 2 points, and we're finished.